All right, so another important thing that we might want to know about an annuity is its present value. Okay, so you've got some periodic payments into the future, and you want to know what's the present value of those periodic payments. One example of that would be if you're buying something and it's on an installment plan and you're paying, $50 a month for however many months, and you'd like to know, okay, well, what does that mean as far as what's the present value of those future payments? Okay, same thing with like a home loan. Oftentimes you might get to a point where, okay, maybe you've got some extra cash and you want to just pay off your loan now, right? Rather than pay all those um, future payments, and you want to know how much would it take to pay off my loan now? Because if you're paying it now, you shouldn't have to pay the interest, right? So anyway, that's another application of the present value of an annuity. So the present value of an annuity is the current lump sum value of periodic future payments using a specific interest rate. All right. So let's figure out how to calculate that. All right. So we have our formula for the future value of an annuity, right? We have this formula right here. 1 plus I to the n minus 1 all over I. Okay. Now, you don't have to memorize this formula. You will be able to use a formula sheet on exams and quizzes. But you should have a formula sheet handy. Okay, so that's telling us the future value of an annuity. Now, we can also determine the future value of some principal invested now and earning interest at that same rate, okay? Just from our compound interest formula. So the future value, now what we were calling that A before, right? That was our future value. That's the accumulated amount in the future. But this is a future value, right? This is a future value. Future value. And this is also a future value. Future value. Okay, just that we were using a different letter. In 5.1, we were using a different letter. But the formula is, it's the principal, which is again the present value, 1 plus r over m to the mt. That's the formula we were using in 5.1 in that section. Now, you notice we're using I and n in the annuity formula. So I'm going to actually replace r over m with I. So this is equal to 1 plus I, right? That's the interest rate per conversion period, times the number of conversion periods, because that's what m times t is. It's m conversion periods per year times t years. So that's the same as n. All right, just so we're using consistent variables here. All right, so we want to know essentially when for these two investments to be equivalent, their future values have to be equal. Okay, so we can actually set these equal to each other and come up with a present value. Solve for the present value, because this is the present value, even though it's also principal, but this is also the present value. Present value. Okay, and so we're going to use the present value times 1 plus I to the n, right? That's the future value if we just deposited it now, right? And just took the money and deposited it and let it earn interest. And we want to set that equal to the future value of these periodic payments. So that's going to be r times 1 plus I to the n minus 1 all over I. Okay, so I'm just setting those two values equal to each other, these two future values. All right, so now we just want to solve for p. So I'm just going to divide both sides by this 1 plus I to the n. So, or I can also, what I could do is just multiply both sides by 1 plus I to the negative n. All right, so either way you can think of it. So I'm going to, Control Z, because I want to solve for p. So what I end up with is 1 plus I to the minus n, which is minus n, right? Which is essentially the reciprocal of this, which is the same thing as dividing both sides by that amount. Then r times 1 plus I to the n minus 1 over I. And that's a formula. But let's clean that up a little bit. We can make that a little nicer. What I'm going to do to make it a little nicer is just distribute this through the numerator. And then I end up with r times, now when I multiply 1 plus I to the n times 1 plus I to the negative n, I just end up with 1. And then when I multiply 1 plus I to the negative n times minus 1, then I'm going to get minus 1 plus I to the minus n. And then that's all over I. Whoops, I. It's supposed to be an I. All right. Oops, Control Z. Let's make that a little nicer. Still not nicer. Okay. That's supposed to be an I. All right, so now I have a formula. It's just still kind of ugly, but it's no worse than than the formula I have for the future value of an annuity. All right, because now that's our formula for the present value of an annuity. So the formula is that the present value of an annuity is equal to the monthly payment times 1 minus 1 plus I to the minus n all over I. Okay, that's another formula that we're going to add to our formula sheet. So now let's go on to example 6 and practice using that formula. Okay, I don't know if I can get them both. No, I don't think I can get them both on there. So jot it down so you can refer to it. All right, so in example 6, they're asking, find the present value of an ordinary annuity consisting of 60 monthly payments of $100 each and earning 6% at per year compounded monthly. All right, so our monthly payment is the R value, right? That's $100. Our nominal interest rate, which is lowercase r, is 0.06. Okay, we have 60 monthly payments, and that's compounded monthly. So our M is 12. Oops. Our M is equal to 12, and the T is 5 years. 5 years, okay, or 60 monthly payments, right? So now we have everything we need to put to use the formula for present value. So it's equal to 100 times that thing in square brackets. So 1 minus 1 plus 0.06 over 12. And then times the number of payments. So minus to the negative, right? So it's negative n, which is negative 60. And then all over the interest rate per conversion period, which is 0.06 over 12. All right. So again, use your calculator. What do we get? We get $5,172.56. Okay. So you could interpret that in a number of different ways. You know, if you were expected to pay $100 a month for 60 months at 6% interest, then you could pay instead this lump sum present value and pay off, if that was a loan, right? You could pay it off by paying in $5,172 rather than paying the $100 per month over 60 months. Okay, that would be equivalent. So you know, another thing would be if this was if they were paying you, right, $100 a month for 60 months, and rather than take that in 60 monthly installments, maybe you want to get the lump sum, get it up front, get it over with. Then you would essentially get $5,172.56, right? That would be equivalent to 60 monthly payments at $100 each at 6% interest. Okay, so anyway, so there's the example 6, and I will meet you in the next video for the last example.